Okay, you may have noticed that the angles in example 2 have a sum of 360. Why is that? Well, all those angles added together make one full revolution. Well, it turns out that the corresponding set of intercepted arcs also contains the entire circumference. So we would say the sum of their measures is 360 degrees also. So the sum of the measures of all of these arcs is 360 degrees. And that is not a coincidence because the arc measure and its corresponding central angle, those measures are the same. So if we look at this picture right here, the central angle in this picture is angle BAC. So the measure of angle BAC is equal to the measure of its intercepted arc. And this is how we would write that, the measure of BC with the arc over top of it. All right, so central angle measure is equal to intercepted arc measure. Okay, that's what we're going to work with now. Now we're going to go ahead and apply it. All right, so number 1. We want to find the measure of the arc or central angle indicated. Assume that the lines that appear to be diameters are actual diameters. Well, if you look at number 1, there doesn't appear to be any diameters, so let's look what we can find. The first piece of information we're given is that arc FE is 45 degrees. Well, that would mean that angle FAE is also 45 degrees because we just learned that arc measure and central angle measure are the same. All right, so if angle FAB is 90 degrees, what would be its intercepted arcs measure? Well, that would be the arc FB, and its measure would also be 90 degrees. Let's look at the next one. This time we know that arc CD has a measure of 60 degrees. So its angle, the central angle that intercepts that would be angle CAD. It would also have a measure of 60 degrees. So that's just as straightforward as it gets. Whatever the angle measurement is, the intercepted arc is the same. Okay, the problems will get a little bit more complex. Let's look at the next one. All right, again, I don't see anything that looks like a diameter anywhere in the picture, so let's see what we have. We know the measure of angle KGL is 45 degrees, so its intercepted arc is also 45 degrees. So we would say the measure of KL is 45 degrees. Next, we know the measure of angle JGK is 60 degrees. So its intercepted arc, which would be from G to K, that would be the arc that would be intercepted by this 60-degree angle. That would also be 60 degrees, and that would be arc JK. All right, next we are asked about the measure of angle LGM. So LGM. Oh, I lied. There's something in this picture that looks like a diameter. Actually, two somethings. Sorry about that. So we're going to use actually this diameter right here to help us find this missing angle measurement, angle LGM. Well, altogether, these three angles have to make up 180 degrees since JM is a diameter. So 180, subtract 60 and 45, and you get, that's 105, so you get 75 degrees. So this missing angle measurement is 75 degrees. All right, the corresponding arc that goes with that angle measurement would be ML, 75-degree angle intercepts ML. So ML also has a measure of 75 degrees. Okay, next I'd like to know what the measure of IM is. What is the measure of arc IM? So it's helpful in a problem like this to find out what is the angle that's making that. So angle IGM is the angle that is making that arc. And there's a couple ways to figure this out, but probably one of the most straightforward ways is to use this linear pair right here. Those two next door neighbors add up to 180 degrees. So if we subtract 75 from 180, we get 105 for this angle. So the arc that it intercepts is also 105 degrees. So the measure of angle IGM is 105 degrees. Now we normally don't find both the angle and the intercepted arc of all of this. I'm just trying to show you the chart so you can start to organize this information. Okay, JI is the last one, and there's a couple of ways of thinking about JI. Right away I'm noticing vertical angles. I'm not sure if you are, but these two lines intercept to make this angle, and it's vertical to that 75-degree angle. So we have a 75-degree angle right here, so the arc is also 75 degrees. So the measure of arc JI is 75 degrees, and the angle that makes that arc, JGI, would also be 75 degrees. All right, and next we're going to think about some of the things that we can use or have used in those problems before we move on to the next set of problems. So I know it only says 2 videos on the board, but there is a 3rd video for you to watch for this lesson. So watch video number 3 to finish up this lesson.